Hello everyone, welcome to the recording for topic 9 where we will be exploring about the common misconceptions on inquiry given by the educators, science educators. Okay, so the learning outcome for this topic would be the first one is to be able to explain what is inquiry. So this is based on your knowledge in the chapters that we have learned before this. And secondly is to be able to describe the different ways of how inquiry is being misperceived, right? So we are going to look at, in this chapter, we are going to look at, I think, four common misconception. Sorry, there's 1, 2, 3, and 4 misconceptions that we are going to look at. So the first one is that inquiry is not an either or proposition. Okay, so inquiry is not something that it is there or it's not there. Okay, it can be a blend of a lot of things. Now, if you remember, inquiry-based teaching is part of many standards and curriculum documents that we have explored in chapter 1. Okay, so for example, if you look at this one, this is extracted from the standards of our national curriculum, where we can see inquiry discovery approach here is being highlighted in page 18, and this is from the IPC. Okay, so we can see that inquiry is part of many standards and curriculum documents here, and if you look at all the documents, you will realize that neither document recognizes it as the sole approach of how science should be taught. So science teaching here should encompass a wide range of methods. Even within the realm of inquiry teaching, there's a wide spectrum of approaches, and also remember that I said that it's a continuum where we can see the different degrees of inquiry in a lot of teaching, in a lot of activities. So teachers, or you as a future teachers, are or must decide on a method that is most productive for you to accomplish your objectives in learning, such as for example, you want them to develop conceptual understanding, or do you want them to be able to do inquiry investigation, or just merely experiencing what science is. Okay, so you are to decide on the method and find or use a check and balance kind of method. Hands-on activity, reading, scheme building activities, films, videos, inquiry investigation, and so on are all important tools when you use it properly, or you use them properly. So for educators, your goal again is to create a balance in terms of pedagogical approaches, student-driven investigation, and also your direction, teacher's direction. So if you draw too tight a line between inquiry and other educational methodologies, you sort of weaken the possibility for successful science education reform. Okay, so bear that in mind, that inquiry is not an either or proposition, but it's a blend in between, and it exists hand in hand with other methodologies which you as a teacher will deem best for your classroom. Second common misperceived conception about inquiry is that teachers normally think that all hands-on activities are inquiry, but the correct conception is all hands-on is not inquiry, and not all inquiry is hands-on. There are many high-quality hands-on science curricula and materials that are available for classrooms today. You can just easily Google up, and based on your judgment, you can easily look for high quality hands-on science curricula and materials out there. However, using hands-on method does not always ensure effective science teaching. You have to remember that. And it's not necessarily indicative of an inquiry-based approach. Okay, so like what we have learned in the chapters before, when children are doing inquiry, it is normal, or one of the facets that we can see is that they have opportunities to raise their own question, and then they can plan, design, and also conduct their own investigation to help them answer the question or some of the questions that they pose or the teacher has given them. And we can see that students are normally in inquiry, they are given ample time to reflect, they are able to engage in dialogue in order to develop their conceptual ideas, and also to in a higher level they are able to defend their findings to others. Okay, so you can see that science inquiry allows students to take ownership of the process or of the learning, which means it gives them opportunity to get connected with questions that are of interest to them, and then they need to find answers to those questions. Okay, so that's basically how inquiry is. Now if you let them do hands-on, so you have to be careful that hands-on activity can fall under the category where it's not actually inquiry. Okay, so inquiry involve a lot of students taking ownership of their own learning. Okay, however, when we say ownership of their own learning, it doesn't mean that every child must work from his or her own question, or they have to pursue an independent investigation. Okay, it can be just as simple as students or investigation which results from one whole class working on the same question, or small groups of children working on a different question. Yeah, so I think you can remember when we studied about the structural inquiry and also the guided inquiry. We are talking about the less intense degree of inquiry. Okay, and that reflects how the intensity of ownership that the students can have while they are doing inquiry. Now, another thing that was not mentioned before is that when an inquiry approach is given to students, it implies that active learning and the development of higher order thinking skills are being engaged. Okay, so hands-on methods are not the only way to achieve this goal. Other resources, for example, can be used to stimulate questions and providing information, and that itself can be inquiry, where things like books, article, information from the internet, personal conferences or interviews can all be used to provoke initial interest in a topic from which research or investigation may emerge. Okay, so that can elicit inquiry on its own. It doesn't necessarily have to be hands-on or students putting their hands on something, right? So things like books, articles, things that I've mentioned before, it does not only necessarily be the resources, but it can also provide additional support once investigation has begun, and that serves as secondary materials for the students. Okay, so that's the second misconception. The third one here is on the content and process dichotomy. Now, imagine in your head a classroom which is using a lot of inquiry. Okay, let's say you are observing a lesson, an inquiry-based lesson. How do you think, or what do you think is the focus of the lesson? Is it the content, which is, let's say, learning about inertia, or is it the process where the teacher emphasizes on how the students develop the skills of forming hypotheses, which is the focal area of that lesson? So this is the question asked of you here. Should the primary focus be the content or the process when an inquiry-based lesson is being executed? Now, if you look at science, it is a unique knowledge because science is a duality where it can be both a method and a set of ideas, right? So when we talk about method, it looks like a process where we are trying to justify things that we claim in the hypothesis. And if it's a set of ideas, then it looks more like a product, okay, where it is in the form of knowledge where it is being used to explain things, like your experiences, your new experiences. Okay, so if research have shown, or if you look into the literature, we can see that both content and process are crucial or are critical, and emphasizing one to the exclusion of the other is not beneficial to students. So as a teacher, the right conception when we are carrying out an inquiry-based lesson is to have an emphasis on both, okay, both the content and the process. All right, so as mentioned, because science is a duality, process of science that I've mentioned in the method here is a way of finding out information, and a set of ideas where it refers to the product of science are ideas that can be applied to understand experiences. All right, so teacher have to emphasize both process skills, sorry, teacher have to emphasize on both process skills and content, where they move forward and back, and they explain it to the students. Right, so the fourth part, or the fourth misconception about inquiry is that inquiry teaching is chaotic, right? So the correct conception here is inquiry teaching is not chaotic. It is in fact a carefully planned or choreographed activity which happens in the classroom. So if we look at traditional methods, we see that inquiry teaching demands a different relationship between teacher and student. It requires more or higher level of organization, planning, and as well as structure, both by the teacher and the students. All right, so in essence, a classroom environment that is supportive and conducive to doing inquiry must be consciously developed by the teacher. Hence, teacher's role here is very vital, where a teacher must create a climate for doing inquiry. And it's as mentioned in the previous topics, teacher's role in the inquiry based lesson is very much active and a dynamic one, where they have to act as facilitator or guide, and teachers identify a set of carefully crafted big ideas. So big ideas here would mean a conceptual framework from which children develop their investigation. Okay, so this conceptual framework is a basis for guiding students to learn something deeper about a scientific concept. All right, so it can be a big idea that talk about chocolate, and it actually brings you to understand how does a cocoa plant thrive in a tropic country, for example. Okay, so during the inquiry process, the teachers normally, because he or she is a facilitator, the teacher walks around the room interacting with groups of students while they are experimenting. So this teacher would normally listen to their questions and ideas, continuously assessing their progress. Hence, there's assessment for learning and determining the appropriate next step for the learning. So that create a rich physical environment. Okay, so in order for inquiry to be effective, a teacher must also lay a foundation in which students can begin to take more responsibility of their own learning. So that's the whole crux about having inquiry-based lesson. We give ownership to the students. A teacher has to then once you have created conducive physical environment. He also must create he also must teach the children on how to organize and manage material. So that's part of a rich physical environment, right? And also we have teachers also have to demonstrate a supportive social environment in which he encouraged students to work collaboratively in small and large groups, participate in discourse, and also to learn and respect each other's idea, or when the students are defending their findings and things like that. All right, so that's the whole chapter, I think, where we have explored about the four different common misconceptions that is common among educators or teachers alike. Okay, so yes, this is a very brief chapter, and I hope that you will remember that four and see that you are able to describe the different ways of how inquiry is being misperceived. Okay, that's all. Thank you.